Hello friends, welcome back to IQNest. In today's video, we would be discussing about one of the important topic in chemistry, that is metallurgy. So this will be the part 4 in chemistry, and in the previous videos we already discussed about atom model, periodic table and various elements in periodic table. So if you haven't watched those videos, please do watch, and if you like it, please subscribe our channel and support us. So friends, without further delay, let's start with today's topic, that is metallurgy, that is chemistry part 4. So the first point is, metallurgy is the process of extraction of pure metal from its ores. The next point, minerals are compound of a metal found in nature. Ores are minerals from which metals can be economically and easily extracted. Gangue are earthy impurities like sand, rocks and limestone associated with an ore. Flux is the substance added to the ore to remove the impurities. Acidic flux and basic flux are the two kinds of flux. Acidic flux is added to remove basic impurity, while basic flux is added to remove acidic impurities. Slag is a fusible material which is a combination of gangue with flux in ores. Prior to the extraction of the metal from the ore, it is necessary to separate the ore from the gangue. This separation can often be achieved by physical means, since minerals and gangue separately occur as separate solid phases. The process of removal of gangue from the ore is technically known as concentration or ore dressing, and the purified ore is known as concentrate. The various steps used in metallurgy are as below. So there are mainly 4 steps which are involved in a metallurgy process. The first one is dressing of the ore. The second is conversion of the enriched ore into oxide of metal. The third one is extraction of metal from the metal oxide. And the last one is refining or purification of the metal. So we'll see each of these metallurgy process in detail in the coming slides. The first one is dressing of the ore. So an ore mined from the earth crust contains gangue which must be removed. The ore free from the gangue then becomes suitable for subsequent treatment. Dressing of an ore is carried out by the following methods. So here comes the methods of dressing. The first one is gravity separation or hydraulic washing, also called levitation. So gravity method is based on the difference between the densities of ore particle and gangue. It is used for the concentration of denser ores from the water soluble and lighter impurities, that is gangue. Generally, metal ores are heavier than gangue associated with them. By flowing the powdered ore in a current of water, the lighter rocky impurities can be washed away and the ore particles are left behind. There are two gravity concentration methods which are jigging and tabling. So there are 2 concentration methods available. The first one is jigging and the second one is tabling. So what is jigging? Jigging is removal of the lighter portion of the ore by means of a stream of water or air which rises through a bed of coarse ore particles, while tabling is passing a mixture of ore and water over an inclined vibrating table. So what is jigging? Jigging is the removal of lighter portion of an ore by means of a stream of water or air which rises through a bed of coarse ore particle, while tabling is the passing of mixture of ores and water over an inclined vibrating table. The next point, Oxide ores and carbonate ores are concentrated by this method. Gravity separation process is used for the concentration of hematite. So the next kind of separation is magnetic separation. So what is magnetic separation? This method of separation is used when either of the ore particles or the gangue associated with it possess magnetic properties. The next point, this method is also used for the separation of the two minerals when one of them happens to be magnetic. The magnetic minerals can be separated from the non-magnetic by this method. The next point, an example for magnetic separation, chromite, that is chromite FeCrO, being magnetic and can be separated from the non-magnetic siliceous gangue by magnetic separation. Next is froth flotation. So what is froth flotation? So this is the process in which sulfide ores of copper, lead and zinc are generally concentrated by this method. So through froth flotation, sulfide ores of copper, lead and zinc are generally concentrated. The next point, the finely powdered ore is mixed with water and a small amount of oil in a tank. Air is blown into the mixture. A froth or scum is produced at the surface. The ore particles are carried by the froth to the surface. The earthy impurities sink to the bottom. The froth along with the ore is removed. An acid is added to break up the froth. The concentrated ore is then filtered and dried. So that was the froth flotation. And the next point is leaching or chemical separation. So what is leaching or chemical separation? So this is a chemical method of concentration. In this method, the powdered ore is treated with certain reagents which dissolves the ore, leaving behind the impurities. The impurities remain undissolved and are removed by filtration process. Leaching method is used for concentrating ores of aluminium, silver, gold, etc. For example, bauxite, that is Al2O3 to H2O, is concentrated by this method. The next separation method is liquefaction. This process is used to concentrate the ores whose melting point is lower than that of the impurities. The impure ore is heated, the ore melts and flows along the surface, the impurities are left behind. Stibnite, an ore of antimony, is concentrated by this method. So that was the liquefaction method. Now the next stage of the metallurgy, that is conversion of the enriched ore into the oxide of metal. So that is the second step. So it is easier to obtain metal from their oxides than from their carbonates or sulfides. Hence, the concentrated ore is converted into the oxides of the metal, which is then reduced into metal. This conversion to oxide is done by the process of calcination or roasting. So, how are we doing this conversion? So, this is being done by the calcination and roasting. So, what is calcination? Calcination process of heating. This is a process of heating concentrated ore in the absence of or in the limited supply of air below its melting point. So calcination is the process of heating concentrated ore in the absence of air or in the limited supply of air below its melting point. It is done for hydroxide or carbonate ores. It is done in a reverberator furnace. So calcination is done in a reverberator furnace. Now what is roasting? Roasting is the process of heating the concentrated ore in excess of air. So calcination was done in the absence or limited supply of air, and roasting is being done in an excess of air. It is done for sulfide ores, and it is done in a reverberator furnace. So both calcination and roasting are being done in a reverberator furnace. So that was the conversion process. And next step is extraction of metal from metal oxide. A metal oxide thus produced is then reduced into metal. For this, the method used depend upon the reactivity of the metal being extracted. So following are the methods used in the extraction of a metal from a metal oxide. The first one is reduction by heat alone. Metals occupying lower positions in the activity series can be obtained by heating their oxides. The activity series is a list of metal arranged in the order of decreasing ease of oxidation and increasing ability to take an electron. The next process of reduction is chemical reduction. Metal in the middle of the activity series, that is Fe, iron, zinc, nickel and tin, that is Sn, etc., cannot be obtained by heating their compounds alone. Okay, that cannot be extracted by the reduction by heat alone. So the chemical reduction method is used. Okay, they require to be heated with a reducing agent, usually carbon, that is coke. When a metal oxide is heated with carbon, it is reduced to free metal. Smelting is the process of heating oxides of elements with coke and flux above their melting point. So that is the chemical reduction process. The next step in metallurgy is refining and or purification of metal. This is an important step in the metallurgy, that is refining. So metals obtained by reduction process still contain some objectionable impurities and hence have to be refined. Some commonly used methods of refining are as below. So here comes the methods in refining. The first one is distillation. So what is distillation? Certain metals such as zinc and mercury have a very low boiling point. So on heating them, they readily vaporize, thus leaving behind their impurities. The impure metal is heated beyond its melting point in a furnace and the vapors are reconverted to metals once the impurities are separated. So that is the distillation process. The next one is liquidation. So what is liquidation? This method is used for the metals with low melting point, for example tin. In this process, the impure metal is heated and then it is made to flow on a sloped surface. The impurities will remain behind and the pure metal will collect at the bottom of the slope. So that is the liquidation process. The next one is electrolytic refining. This is one of the most common and widely used methods because it is applicable to most of the metals. In this method, the different electrochemical properties of the metals and the impurities are considered. In this process, the impure metal is the anode, the cathode is the sheet of pure metal. The electrolyte is the solution of the salt of the same metal. Then an electric current is passed through the solution. The pure metal from the anode will dissolve in the electrolyte bath and then it is collected at the cathode. The impurities will either dissolve or be found in the heap at the base of the anode. So for example, copper refining is done by the electrolytic process. The impurities such as iron, zinc will dissolve in the copper sulfate solution and other impurities such as gold or silver or platinum will remain behind. So this is the process of electrolytic refining. Now we'll be seeing another kind of refining that is an important refining that is being used in metallurgy, that is zone refining. So what is zone refining? Zone refining is a special method used to purify metals. It was the invention of William Fan. So the zone refining process was invented by William Fan. It purifies metal to a very high degree. A rod of impure metal is placed in a container which is filled with inert gas. A circular heater is then placed around the rod at the top. The impure metals heats up due to the circular heater. When the heater shifts to the next zone, the pure metal cools and crystallizes. The molten impurities move along with the movement of the heater and shift to the next zone. These impurities collect in the last zone and then it is separated. So that is the process of zone refining. Now we will be seeing another refining method, that is chromatographic method. So what is chromatographic method? This allows the principle of chromatography. Chromatography deals with the movement of components at different rates in a mixture or differential absorption of an absorbent. In this process, an impure metal is put in a medium, that is liquid or gas, then the medium is made to move through an absorbent. Different components of the impure metal will absorb at different levels, and then the components that were absorbed are removed by using a suitable solvent. So that is the chromatographic method. So we have seen the different steps involved in the metallurgy process and different various kind of methods of process used in the metallurgy in chemistry. So friends, that's it for today. So if you like this video and if you feel that this video is informative, please like it and subscribe our channel and support us. Also please press the bell icon so that you can get the notification of all the new videos that will be uploaded in this channel. I will meet you again with another informative video. Thank you for watching and have a good day.